A signal from space is breaking the rules. It does not behave like noise. It does not fade into randomness. It repeats. Scientists expected static. They found a pattern, and it is coming from a place that is not far away in cosmic terms. That changes everything. For decades, the search for intelligent life beyond Earth has followed a familiar path. Scientists point powerful telescopes into the sky. They listen. They scan the darkness for whispers of something unusual, something artificial, something that does not belong to nature. Most of the time they find nothing, or worse, they find something that looks promising at first and then collapses under closer inspection. A strange signal turns out to be a dead star spinning rapidly. A burst of energy turns out to be a black hole feeding. A mysterious pattern turns out to be interference from Earth itself. Again and again, the universe teases. Then it explains itself. That is why scientists are careful. That is why they are skeptical. Because the universe is very good at creating illusions. There are neutron stars that pulse with such precision that they were once mistaken for alien beacons. There are cosmic explosions that release more energy in seconds than the sun will produce in its entire lifetime. There are radio waves that travel across galaxies, distorted and stretched, arriving here as strange signals that seem almost designed. But in the end, nature always wins. Until now, that has been the rule. But this time, something feels different. The signal did not just appear and vanish. It did not behave like a chaotic burst. It showed structure. That single detail is what stops scientists in their tracks, because structure means order. Order suggests a process, and a process raises a dangerous question. Could this be intentional? The discovery did not come with celebration. It came with silence. Careful analysis, repeated checks, independent verification. Scientists tried to prove it wrong. They tried to find the flaw, the error, the natural explanation hiding beneath the surface. But the more they looked, the stranger it became. The signal repeated in a way that did not match known cosmic sources. Its timing was unusual. Its energy profile did not fit cleanly into any category that scientists understand today. Even more unsettling, it seemed to be coming from a region that is not impossibly far away. In the scale of the universe, distance changes meaning. Something that is thousands of light years away can still be considered close. Close enough to matter, close enough to study, close enough to raise serious questions. And that is exactly what is happening now. Because when something this unusual appears nearby, scientists cannot ignore it. They begin to ask harder questions. Is this a rare natural phenomenon that has never been seen before? Is this a known object behaving in a completely unknown way? Or is this something else entirely? For the first time in a long time, the answer is not clear. That uncertainty is what makes this moment so powerful. Science depends on explanations. It depends on models that describe how the universe behaves. When something does not fit those models, it forces a shift. It forces new thinking. Sometimes it leads to breakthroughs that rewrite entire fields. But sometimes it leads to something far more unsettling. The possibility that we are not alone. That idea has existed for generations. It has been explored in theories, in equations, in quiet discussions inside research institutions around the world. But there has always been a gap between belief and evidence, a gap that has never been fully closed until signals like this begin to appear. Signals that refuse to behave. Signals that refuse to disappear. Signals that carry just enough structure to raise suspicion, but not enough to provide answers. That is where things stand right now. Scientists are not claiming discovery. They are not announcing contact. They are not jumping to conclusions, but they are paying attention, very close attention, because hidden inside the signal could be something that changes the direction of human history. Or it could be another illusion, another trick played by the universe. That tension is what makes this story different from everything that came before. It is not just about the signal itself, it is about what it represents. For the first time in years, the line between natural and artificial feels slightly blurred. And that is a dangerous place for science to be, because once that line begins to move, even slightly, the questions become much bigger. If this signal is natural, then the universe is capable of behaviors that we still do not understand. But if it is not, then we are no longer alone in the way we once believed. And that possibility, even without proof, is enough to shake the foundation of everything we think we know. In this video, you are going to learn exactly what scientists discovered. You will understand why this signal stands out from everything else detected before. You will see the competing explanations that researchers are testing right now. And most importantly, you will explore the question that no one can answer yet. Is this just another cosmic mystery? Or is this the first real sign of intelligent life beyond Earth? Stay with us until the end, because the deeper this story goes, the more unsettling it becomes. There are details that most people have not heard. There are patterns that raise serious questions, and there are possibilities that scientists are only beginning to consider. This is not science fiction. This is happening right now. Welcome to the channel. Subscribe for more deep dives into the universe and the biggest questions humanity has ever asked. The discovery did not begin with excitement. It began as a routine scan. Deep in the silence of space, a network of radio telescopes was listening. These instruments scan the sky every day, collecting vast amounts of data. Most of it is noise, random signals, natural radiation from stars, galaxies, and distant cosmic events. On this day, something stood out. At first, it looked small, just another signal buried in the data, but it did not fade like the others. It came back again and again. That was the first sign that something was wrong. Natural signals from space are usually chaotic. They spike, they drop, they scatter across frequencies. They do not repeat with precision. They do not follow a clean rhythm. This one did. The signal showed a pattern, a clear, measurable interval between bursts. Each pulse carried energy in a way that looked structured, almost organized. It was not perfectly uniform, but it was far from random. That detail changed everything, because in the search for life beyond Earth, scientists are not just looking for signals, they are looking for patterns. Patterns suggest control. Patterns suggest intent. The signal was traced back to a region within our own galaxy, not billions of light years away, not at the edge of the observable universe. Close enough to study in detail. That alone made it unusual. The discovery came through powerful radio observatories designed to detect faint emissions from space. These instruments are sensitive enough to pick up signals that have traveled across vast distances. They can detect the afterglow of ancient cosmic events. But this SIG now was different. It was not a one-time burst. It was not a distant explosion. It persisted. The data was checked immediately. Scientists ran verification tests. They looked for interference from Earth, satellites, communication systems, even nearby electronic devices. Nothing matched. The signal remained. Then came the second wave of analysis. Independent teams reviewed the data. Different observatories pointed their instruments at the same region of space. They wanted to confirm that this was real. It was. The same pattern appeared again. At that moment, the mood shifted. This was no longer a routine observation. This was a mystery. Still, caution remained. Scientists have been misled before. In the past, signals that looked artificial turned out to be natural phenomena. Pulsars are a perfect example. When they were first discovered, their precise pulses led some to believe they were signals from intelligent beings. That idea disappeared once their true nature was understood. No one wanted to repeat that mistake, so the analysis became more intense. Every possible natural explanation was tested: rotating neutron stars, magnetars with extreme magnetic fields, exotic cosmic objects that are not fully understood. Each theory explained part of the signal, but not all of it. There were gaps, and those gaps kept the mystery alive. As the data spread through the scientific community, attention grew. Researchers from different fields began to examine the signal: astrophysicists, radio astronomers, data analysts. The same question kept returning: why does this signal behave like this? News of the discovery did not stay contained for long. Once it reached the broader scientific world, it began to attract global attention. Not because scientists claimed it was alien. It did not. They remained careful with their words, but the characteristics of the signal were enough to raise eyebrows. A repeating structure, a persistent source, a location that is relatively close in cosmic terms. These are not common features, and when they appear together, they demand attention. Quiet discussions began, papers were prepared, observatories scheduled more time to study the source. The goal was simple: understand it, explain it, remove the mystery, but the more data that came in, the harder that became, because the signal refused to behave like anything known. And that is when the discovery truly began to change everything. Most signals from space are messy. They rise and fall without warning. They stretch across frequencies in uneven ways. They look like static. Even the most powerful events in the universe often leave behind chaotic fingerprints. Supernova explosions scatter energy in all directions. Black holes feeding on matter create violent, irregular bursts. Even distant galaxies produce radio waves that blend into a kind of cosmic background noise. There is order in the universe, but it rarely shows itself in clean, repeating signals. That is why this one stands out. The pattern is not perfect, but it is consistent enough to be measured. The signal appears, fades, then returns after a specific interval. Not exact to the millisecond, but close enough to raise serious questions. The spacing between bursts follows a rhythm that does not match typical random behavior. Each pulse also carries a distinct energy profile. It is not just the timing that is unusual. The strength of the signal changes in a way that suggests a process behind it. Some bursts are stronger, some are weaker, but the variation itself seems controlled, not chaotic. That detail is difficult to explain. Scientists immediately compared it to known sources. Pulsars were the first candidate. These are rapidly spinning neutron stars that emit beams of radiation. As they rotate, beams sweep across space like a lighthouse. From Earth, this creates a repeating pulse. Pulsars can be incredibly precise. Some are so stable that they rival atomic clocks. That is why early researchers once considered the possibility that pulsars were artificial signals, but this signal does not fully match pulsars. The timing is less stable. The energy pattern is different. Pulsars usually produce very regular, predictable pulses. The signal drifts, it shifts slightly, it behaves with a kind of irregular consistency that does not fit the pulsar model. Then came magnetars. These are extreme versions of neutron stars with magnetic fields so powerful that they can distort space itself. Magnetars can produce intense bursts of energy, including radio waves. Some recently discovered signals, known as fast radio bursts, have been linked to magnetars. These bursts can repeat, which makes them a closer match. But again, the comparison falls short. Fast radio bursts are usually brief and extremely energetic. They appear suddenly and then disappear. Even repeating ones tend to follow patterns that can be traced back to known physical processes. This signal sits in between categories. It is not as stable as a pulsar. It is not as explosive as a fast radio burst. It is not as random as background noise. It occupies a strange middle ground. That is where the problem begins, because science depends on classification. When something fits into a known category, it can be studied, modeled, and understood. When it does not fit, it creates uncertainty. And uncertainty opens the door to more complex possibilities. One of the most unsettling details is the structure within the signal. Not just repetition, but variation within repetition. It is not a simple on and off pattern. It carries subtle changes that appear almost coded, though no clear message has been identified. This does not prove intelligence. Natural systems can produce complex patterns. Weather systems on Earth show structure. Planetary atmospheres create repeating cycles. Even chaotic systems can produce temporary order. But the level of structure matters. And this signal sits right on the edge, too organized to ignore, too irregular to explain easily. That is why scientists are struggling. Current models can explain parts of the behavior, but not the full picture. Each explanation leaves gaps. Each theory answers some questions while creating new ones. And in those gaps, a different kind of thought begins to form. Not a conclusion, not a claim, just a possibility. Because when a signal carries repetition, variation, and persistence, it begins to resemble something more than a natural accident. It begins to resemble a process and a process and a process and a process under the right conditions can point towards something deliberate. The signal is not coming from the edge of the universe. It is coming from within our own galaxy. That detail changes the scale of everything. The Milky Way is vast. It stretches across more than 100,000 light years. It contains hundreds of billions of stars. On that scale, even a distance of a few thousand light years is considered close. This signal falls into that range, not next door, but not impossibly far. Close enough that its source exists in our galactic neighborhood. Close enough that its signal has not been traveling for billions of years. It is relatively recent in cosmic terms. That makes it far more important. When signals come from extremely distant galaxies, they are harder to interpret. They pass through clouds of gas. They get stretched by the expansion of space. They lose clarity over time. By the time they reach Earth, much of their original structure is distorted. This one is different. It arrives with enough strength and detail to be studied carefully. Its pattern is still visible. Its structure is still intact. That suggests the source is not only closer, but also powerful enough to send a signal across that distance without losing its identity. That is not common. To understand how unusual this is, consider the signals that scientists detect every day. Many come from the far edges of the observable universe. Some have traveled for billions of years before reaching Earth. They are ancient by the time they arrive. This signal is not ancient in the same way. It belongs to our galaxy. to our local cosmic environment. That raises a different kind of question. If something like this exists nearby, why has it not been detected before? Part of the answer lies in technology. Radio astronomy has improved dramatically in recent years. New telescopes are more sensitive. Data processing is faster. Algorithms can detect patterns that older systems would have missed. Signals that once blended into noise can now be separated and analyzed. This means the universe may have been sending signals like this for a long time. We just did not have the tools to notice. There is also the issue of time. Some cosmic signals are not constant. They appear and disappear. They may only become active for short periods. If no one is looking at the right place at the right time, they pass unnoticed. This signal may have been hidden in plain sight. It could have been active before, but ignored or misclassified. It could have been dismissed as noise or interference. Only now, with better instruments and more focused searches, does it stand out. That possibility is unsettling because it suggests this might not be a one-time event. There could be more signals like this scattered across the galaxy, faint, repeating, overlooked. The idea that this is rare begins to weaken, and as that idea weakens, a new thought begins to take its place. F1 structure signal exists nearby. Others might exist as well, not necessarily identical, not necessarily from the same source, but similar in the sense that they break the expected patterns of nature. That would mean the universe around us is not as quiet as it seems. It would mean that signals with structure, persistence, and unusual behavior are not isolated accidents, but part of a larger pattern that has not yet been fully recognized. And if that is true, then this discovery is not just about one signal. It is about the possibility that we are only beginning to notice something that has been there all along. Scientists did not start with bold claims. They started with familiar explanations. The first step was to assume the signal came from a known object. That is always the safest path. Neutron stars were at the top of the list. These dense remnants of dead stars can produce powerful radio signals. Some spin at incredible speeds and create repeating pulses that can be detected across the galaxy. At first, the signal seemed to fit. There was repetition, there was energy, there was a clear source in space, but the details did not hold. Neutron stars usually behave with extreme precision. Their pulses follow a stable rhythm. This signal drifts, the timing shifts slightly, the pattern bends just enough to break the model. That small inconsistency creates a large problem. Then came magnetars. These are among the most extreme objects in the universe. Their magnetic fields are so strong that they can crack the surface of the star itself. When that happens, they release bursts of energy that can be detected as radio signals. Some of these bursts repeat, which makes magnetars a strong candidate. Again, the match looked promising at first, but the energy profile did not fully align. Magnetar bursts tend to be violent and short-lived. This signal shows persistence. It continues. It repeats over time without fading in the expected way. The pattern also carries structure that does not easily map onto known magnetar behavior. So the explanation weakens. Interference from Earth was also tested. This is more common than most people realize. Signals from satellites, aircraft, and ground-based systems can leak into radio telescope data. In some cases, they create patterns that look artificial because they are artificial. That possibility had to be eliminated. Scientists checked known frequencies used by communication systems. They compared timing, location, and signal strength. They looked for overlaps with human technology. Nothing matched. The signal did not behave like local interference. It did not track with Earth-based sources. It remained fixed in space. That was another door closing. Other exotic explanations were explored. Some scientists considered rare cosmic objects that are not fully understood. Others looked into the possibility of multiple overlapping sources creating the illusion of a pattern. Each idea explained a piece of the puzzle. None explained the whole. This is where the gap becomes clear. The data shows structure, repetition, and persistence. The models explain randomness, instability, or extreme bursts. The two do not fully connect. That gap is where uncertainty lives, and uncertainty is uncomfortable in science. It forces researchers to work harder, to question assumptions, to test ideas that might seem unlikely at first, but it also demands discipline. Because one step too far can lead to false conclusions. That is why scientists are careful with the idea of intelligent life. The history of astronomy is filled with signals that looked meaningful but turned out to be natural. Every time a pattern appears, the possibility of intelligence is considered, then set aside until all natural explanations are exact. Instead, that process is slow by design. No one wants to claim something extraordinary without overwhelming evidence. Right now, that evidence does not exist. The signal is strange, it is difficult to explain. It does not fit cleanly into known categories, but it is not proof. That is the tension. On one side, the data refuses to behave as expected. On the other, the scientific method demands caution. The result is a narrow space where questions grow, but answers remain just out of reach. And inside that space, the mystery continues to deepen. The signal did not disappear after it was discovered. That is why the next phase has already begun. Telescopes around the world are now watching the same region of space. Not once, not briefly, constantly. Scientists are collecting more data with every passing day. They are tracking every pulse, every variation, every small shift in timing. The goal is simple: get more information, because one signal can be misleading. 10 signals begin to show a pattern. Hundreds of signals can reveal behavior that was hidden before. That is what researchers are waiting for. Consistency or change. If the signal stays the same, it suggests a stable source. If it evolves, it may reveal a deeper process behind it. Even a small drift in timing or strength can point to something new. That is why observation never stops. New instruments are also being brought into the search. Modern radio telescopes are far more sensitive than older systems. They can detect weaker signals, they can separate overlapping frequencies, they can analyze patterns in ways that were not possible before. Arrays of telescopes can work together, combining their data to create a clearer picture of the source. This method allows scientists to narrow down the exact location with greater precision, and location matters. If the source can be linked to a specific star system or object,
CTT, the range of possible explanations becomes smaller. If it remains isolated with no visible origin, the mystery grows deeper. At the same time, data is being shared across the global scientific community. Teams in different countries are analyzing the same signal.
Independent verification is critical. If multiple groups reach the same conclusions, confidence increases. If results differ, new questions emerge. This is how science protects itself from error. Alongside observation, another effort is underway: decoding. Scientists are studying the structure of the signal in detail. They are searching for hidden patterns within the patterns, subtle changes in frequency, variations in intensity, sequences that repeat over longer periods. Most natural signals follow physical laws that can be modeled. If this signal contains layers of structure beyond those laws, it could suggest something more complex. This does not mean a message is expected. It means the signal is being treated as information, and information can sometimes reveal its origin. There is also a growing awareness of risk. Misinterpretation is a real danger. In the past, signals that looked extraordinary turned out to have simple explanations. A small error in data processing, a hidden source of interference, a natural object behaving in a rare but explainable way. If scientists move too quickly, they risk repeating those mistakes. But there is another side to this. If the signal is dismissed too soon, something important could be lost. That balance is difficult to maintain. Caution slows progress, but it protects accuracy. Curiosity drives discovery, but it can lead to false conclusions. The challenge is to move forward without crossing that line. That is why every step is deliberate. Every claim is tested. Every assumption is questioned. Around the world, researchers are watching closely, not just because the signal is unusual, but because of what it could represent. Observatories are adjusting schedules. Research groups are shifting focus. The quiet discussions are taking place in laboratories and institutions. No one is making bold announcements, but no one is ignoring it either, because if this signal leads to a clear explanation, it will expand our understanding of the universe. And if it does not, then the question it raises will become impossible to ignore. Something has been detected in the silence of space. It repeats, it holds structure, it refuses to fit into what we already understand. That alone makes it important. For decades, the search for intelligent life has moved between hope and disappointment. Signals appear, then fade into explanation. Patterns emerge, then collapse into natural causes. The universe always seemed one step ahead, always just out of reach. This time feels different, not because there is proof, there is not, but because the question itself is no longer distant. It is here, right now. Scientists are looking at a signal that challenges what they expect to see. They are testing every explanation. They are pushing every model to its limit. And still, something does not fully align. It could be natural, a rare object, a new kind of cosmic behavior that science has not yet understood. Or it could be something far more profound. That uncertainty is the most powerful part of this story, because it places humanity in